What's up, everybody? We're going to do 9.5 today, which is about logarithmic equations. So in the last lesson, we kind of learned about, hey, what do we do if we start off in exponential equations? And method one is if I had like 2x is equal to 16, I would have to break the bases down and get the same base. Now if I had something where, we couldn't break something down like this, I can't really break down 17, what I would do is change that into log form and have log base 2, 17 equals x, and then I can do my change of base form. Log of my big number over log of my base. So that was last lesson when we started off in exponential form. Well, today we're going to be starting off into log form. And strategy number 3 is to cancel logs. And this has to kind of do with our duh property. So if I have log base m, or you know what, I'm going to say log base b of m equals log base b n, the two logs can cancel out and we have m is equal to n. Now, what you need for this, you need to have the bases being exactly the same, and you have to have this equal sign. If you don't have that equal sign, you can't just drop logs out of nowhere. That's crazy. Gotta have logs on both sides in order to cancel. So, example number 1. If I have log base 5 of 4x minus 7 equals log base 5 of x plus 5. Let's see. I got an equal sign right here. That's good. I have log base 5, awesome. And cancel those. I can drop the logs. And now I have 4x minus 7 equals x plus 5. Well, this is actually an easy problem that we can solve. If I move the x over, I get 3x. If I move the 7 over, I get 12. So x is equal to 4. Not too bad. Not too shabby at all. If I have, for example, number 2, log 3x equals log 27. I got an equal sign, that's good. If there's no base, I can really assume that the base is 10. Those are the same. 3x equals 27. Divide both sides by 3, and we get x is 9. Good. Again, need the equal sign. You need the same base. Otherwise, you cannot drop your logs. It will be wrong if you drop your logs. We just don't want to be dropping logs out of nowhere. You can land on your foot or something. Alright, so what if we don't have logs on both sides? This is going to be strategy number 4. Strategy number 4. So kind of like when we were in exponential form, we couldn't break down our bases. Well, what if we can't drop our logs? So strategy number 4 is we're going to change to exponential form. So if we remember log base b a equals x, we can change forms and have b raised to the power of x is equal to a. So just quick reminder of that. So, for example, number 3, if I have log base 4 5x minus 1 is equal to 3. Well, I got an equal sign, that's good, but I don't have logs on both sides, so I can't just drop the logs. So what I'm going to do is change to exponential form. So when I change to exponential form, I have my base 4 raised to the third power equals 5x minus 1. Well, if I put 4 to the third in my calculator, I get 64 equals 5x minus 1. And now this is a really easy problem that we can solve. If I add the 1 over, I get 65 equals 5x. Divide both sides by 5, and I get 13 is equal to x. And I just kind of realized there's a big glare on this. That's a bit better. Yeah, that's way better. So, if I have a number 4, I have 2 log 3x is equal to 4. And you may be thinking, hey, I can use the power property, take this 2, move it up to an exponent. I mean, technically, yeah, we could, but why do this? Because really, this is 2 times log 3x. Well, how do we undo multiplication? You guessed it, division. I'll divide both sides by 2 so we can get rid of that. And we have log 3x is equal to 2. So I got an equal sign, I got a log here, but no log here, so we have to change to exponential form. And if we remember, when you don't have a base, you have to assume that the base is 10. So I can write this as 10 squared is equal to 3x. Well, 10 squared is 100 is equal to 3x. Divide both sides by 3. And I get 100 over 3 is equal to x. Fractions are fine. Fractions are your friends. All right. So, not too bad. You may be thinking, what's the catch? Well, maybe this is a catch. I don't know. But it's not too bad. So, strategy number 5. Strategy number 5 is when we have logs on the same side. So if I have like log base b m plus log base bn is equal to, I don't know, x, I have to condense. So strategy number 5 is condensing first. So this would be like log base b, product property, m, when I have addition, that's multiplication, mn equal x, and then we can change to exponential form. So let's try this. So for number 5, I have log 45x minus 3, or log 3. Man. Is equal to 1. Okay, well, if I'm looking, I have to condense first. I have the subtraction sign. Subtraction means divide. So I have log 45x over 3 is equal to 1. Well, 45x divided by 3 is just 15. So I have log 15x is equal to 1. Not terrible. So I have one log now, which is good. I have a log here, equal sign, and just a random number. I can't drop this log. I have to change to exponential form. So my base is 10 here. So 10 raised to the first power is equal to 15x. And 10 to the first power is 10. So 10 is equal to 15x. If I divide both sides by 15, well, 10 over 15 simplifies down to 2/3. So x is 2/3, and that's fine. And may I add, Photomath is not going to help you with this stuff. Photomath is going to give you really, really weird answers, and it's not going to be helpful. And if I catch you using Photomath on this stuff, and I am going to be adding questions that will not work, if I catch you using it, automatic 0. So please don't try it. Alright, number 6. I have log 2x plus log times the quantity x minus 5 equals 2. When I get something like this, well, first I'm going to condense. Addition means multiplication. So log 2x times x minus 5 equals 2. So I just condensed it down. Next thing, I am going to change forms. I'm not going to worry about distributing just yet. I'm going to change forms. This is a base of 10. So this becomes 10 squared equals 2x times x minus 5. So now 10 squared is 100. And if I distribute, 2x times x is 2x squared. 2x times negative 5, negative 10. And if you haven't guessed it already, whenever we get a square here, we're going to have to factor. So I need to set this equal to 0. I'm going to subtract 100 from both sides. So I get 2x squared, this is 3x here, minus 10x minus 100 is equal to 0. First, when we factor, we always look for a GCF. So GCF here, I can factor out of 2. I get x squared minus 5x minus 50 equals 0. And I need two numbers that multiply to negative 50, add up to negative 5, negative 10, and 5 will do just fine. So I have 2 times x minus 10, x plus 5, set that equals 0. Set each one of these equal to 0. So 2 equals 0 can't be true. I get x equals 10 and x, why did I put w? X equals negative 5. For this, logs can't be negative. If you try to put log negative 5 in your calculator, it's going to come up with an error. Always go with the positive value. Always, always, always. So x is equal to 10. Alright. Almost done. One more example. I know this is kind of a long lesson. Sorry. Also suggest popping into Zoom classes or Zoom office hours. They can be pretty helpful. Alright. Last but not least, number 7. Lucky number 7. Log base 4 of quantity x plus 12 plus log base 4 x equals 3. Addition, we have to condense first. Addition means multiplication. So log base 4 x plus 12 times x equals 3. Going to change into exponential form. So 4 is my base. So 4 raised to the third power equals, this is really x times x plus 12. 4 to the third, 64. Distribute, x squared plus 12x Again, when we get an x squared, think factor. Move the 64 over, x squared plus 12x minus 64 equals 0. Any two numbers that multiply negative 64 add up to a positive 12. I have x plus 16 and x minus 4 equals 0. So I'm going to set both those equal to 0. So x plus 16 equals 0 and x minus 4 equals 0. I get x equals negative 16, x equals positive 4. Always go with the positive one. Alright, that's pretty much it. That concludes this lesson. Please let me know if you got questions. I'd be more than happy to help you out. I know this stuff can be a little confusing, so please, 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 I really don't mind. I'd rather you guys reach out than struggle on your own. So let me know.